Hello, my name is Steve Samuel from Design Visionaries, and thanks for attending this little talk. The title of this talk is How Not to Lose Your Job Due to AI. And a lot of folks are afraid of AI, and a lot of people don't know what its impact is going to be. And I think we're all in the dark. But what we do know is that if we embrace this technology, it can be very, very powerful. There's no going back. There was an economist named Richard Baldwin from the Graduate Institute of Geneva in Switzerland, and he said that AI is not going to take your job, but a person who knows how to use AI might. And the fact is, artificial intelligence is here to stay, and when we embrace the power, there's ways that we could look at it with a positive viewpoint and a positive thought process. There's a lot of different things that are going on within the design community and design tools that are powered by AI. So I've got a few examples of that for you today, and hopefully we can look at AI as something that's really positive and amazing. So for one thing, AI gives you a fantastic ability to do iterative design. A lot of design, a lot of really great inventions come from iterations upon things. And, hearkening back to certain things that would have been improved by AI. For example, there was a jet plane developed by the de Havilland Company back in the 50s, and it had 4 jet engines, and it had a pressurized cabin. Here's a little picture of it, and to the surprise of the passengers, there were 3 of them that just exploded, and or 2 of them that exploded due to fatigue. And fatigue is a very real and very important concept in aerospace. And the fact is, the 4 jet engines that it had powered this thing, and it was going so fast that it was faster, and there was more stress on it than ever before, than planes before that. And so the fatigue wasn't that well understood. And so that's why 2 of them fell out of the sky because of that, because of cracks that came with fatigue. So the iterative ability of artificial intelligence and the programming and all the simulation that we could do, if it were only applied to that plane, maybe those lives would have been saved. So artificial intelligence gives you the ability to iterate like crazy on something. There's a game called Go. And in Go, there are many moves that you can make. As a matter of fact, there's more possible combinations of moves than there are grains of sand, I'm told. And so it's fantastic. And recently there was within the last few years, there was a match. The most amazing Go player in the whole planet was pitted against a computer using AI, and the AI learned how to beat the human, and it was an amazing thing that everybody got all excited about. But the thing about AI is it can iterate like crazy, and it could iterate almost virtually at the speed of light. And so there's design abilities that you can get from that. So here's a little example of how AI can affect design. So for example, I've got this little piece of geometry. It's like nice and smooth, and I want to put a radius on these edges here. And what AI does is it says, oh, the edge that you selected is very similar to all these other edges, so all you've got to do is press the button and you'll get all of them. And so that's kind of an example of how AI is now changing. Oh, these are chamfers. That's an example of how AI is changing the ability to design. Maybe a better example is an example that I took from a real life situation where there was a person who was designing a rectilinear battery. And the battery was supposed to fit inside of this odd kind of eggy shape. And this person was iterating upon the battery, if you think about it, if you make the battery long, you can make it, you're going to make it have more volume. The objective was to maximize the volume of the battery. And so if you make the battery long, then what you get is, let's show you, make it 200, is a long, thin battery. Because the battery can't be outside of the surface. And if you make it wide, you can maximize the amount of volume of the battery. But if you make it really long, then it'll feel these surfaces, and then it can't get as high. So for an example, if I make it 300, you can see now it has to neck down a little bit. So the optimization of this volume to make it as volumetric as possible is a matter of iterating upon the overall length of the battery and then the overall width. When you make it shorter, or I guess less wide, you can make it higher. See? So the optimization of this battery is a matter of iterating upon the length and the width. So what I've done here is I've created the basic shape. Let me just turn the model back in time. Make current feature here. So the basic shape was made with these entities. This sketch and this 1, 2, 3, 4 sketches, 3 sketches. And I made a surface out of those using a through curve mesh surface. Great. And then I made a datum plane that was at the end. I made a datum plane that was right in the middle. And then from that datum plane, I made 2 other datum planes that were controlled by a variable. As you can see, if I go to the expressions editor, you'll see that there's a variable b and there's a variable w. So w is the width between 2 datum planes. And then on the smallest datum, or I should say the datum plane at the far end, I made a sketch, a current feature. Let's make current feature. There it is. I made this sketch right here. And this sketch is then controlled by a variable b. So as I change b, the sketch can get wider, but it feels the cross section of the shape. So as it gets wider, it gets shorter. Let me show you that. I'll just say that. And I'll vary the width. Here's the width, b. If I make it 40, as you can see, every time I change the width, it's got to feel this elliptical shape here. Let's make it 100. And it has to get shorter. So then I just extruded that to the next plane. So it makes a rectilinear battery. Okay, so great. So now I did a measurement. I just went into analysis and measure. And I did an object. I set this at solid body. I said body, and I did associative, and I selected that object, and I said OK. And when I did all of that, I got a measurement expression that I called volume. So here it is. So I've got the volume of that shape. So if I didn't have the tools that I have, I would select different numbers for the width and the b, I should say the length, which is w, and b, which is the width of this inscribed rectangle, and I would continually check the volume to see if it's any greater. And I would go back and forth, and it could take me a very long time to do that. But because of artificial intelligence, because of the way that I can iterate so quickly with a CAD tool, and this is an old technique, but it's still in essence, an artificial intelligence technique, I can do that very quickly. And here's how I do it. I say menu, analysis. Get this out of the way here. Menu, analysis, and then I do an optimization. I give the optimization a name, like max vol. Hit enter, max vol. Okay, oh, it doesn't like that character, special character. So I'm going to call it max vol, 2 L's. Okay. And I make sure it's highlighted. And then I click on objective. And my objective is to maximize, here's maximum. And what I'm maximizing is that volume. So I click on volume there and say, okay. So that's my objective, is to maximize the volume. Then I go to variables. And my 2 variables are B and W. Okay? Now, I've got to guess pretty well at the ranges. So my B range, the width of this little inscribed rectangle, let's say can be, it'll start at 20 and it'll max out at maybe 200. And the width, the W, the distance in between these 2 planes, which is really the length, will start at 20 and will go all the way up to 350. This thing's 400 millimeters long, so 350 gets this shape to the very end where it has to get really thin. So there's my numerical values that I hope will produce, as they get iterated upon very quickly, will produce a maximum volume of this battery. So now when I hit the run button, as you can see, NX will try a bunch of different things, bunch of different numbers, and there it goes. It settled upon 2 numbers, so I was basically optimizing 2 variables at the same time. And as you can see, B is 119 and W is 221. And that is the maximum volume that you can have, which is 2.27 times 10 to the 6th millimeters cubed. And so that's how you maximize the volume. And as you can see, it iterated like crazy. So that's a really neat and powerful tool that has been there for a while, but it's still, in essence, artificial intelligence. Here's another example. I have this box, and in the box I have this wrench. And what I want to know is, what's it going to take to make this wrench come out of the box? What's the path that the wrench has to follow? Obviously, if I take the wrench and I move it straight up, it will collide with the top of this box, which has a hole in it that's only a little bit bigger than the lug of this wrench. So the wrench has this shape. And what I could do is go to the assemblies tool. And within assemblies, there's a command called sequence. And assembly sequences is really powerful. And what I do is I do a new sequence, and I'm going to do an extraction path. And the extraction path is here, extraction path. And it's warning me that when I use extraction path, it's got to take away the mating conditions. Okay, great. So now it says select the component that I want to calculate the extraction path for. And what I need to do is show the position that I want this piece of geometry to end up in. So I want it to end up there. Okay, so great. So now I've shown it the position, and I can go ahead and say generate path and say okay. And what you'll see is it's iterating a bunch of times to see what it will take to make a path for this. And you'll see that we can animate it, and it'll be really smooth when it gets done, all these iterations. So right now, it's going through a million different gyrations and hitting the top of that box and doing this much faster than I could as a human being. The fact that it does this automatically means that I can let this go and walk away, and pretty soon it will generate my path. So it is certainly taken its time, but what it's doing here is really a lot of iterations all at once. Looks like it's almost there. There we go. All right, so now after having done all of that craziness, it's like that old adage of, a million monkeys on typewriters, eventually they'll type out world peace. Not world peace, War and Peace, right? Tolstoy's War and Peace. I guess it's Tolstoy. So, so here we go. So now that I've created that extraction path, you can play it. And this is what the wrench has to do to come out of that box. There we go. It's got to make a nice little turn. So NX figured that out on its own, and that is artificial intelligence. Fantastic.